Hello guys, my name is Muhammad Firdaus bin Ahmad Azmi and I am from IAC 5P. And today I'm going to show you how to do my assignments number one, which is just to create a simple IV. Okay, first what we're going to do is go to the block diagram and type Control plus space. You can see a quick drop right here and we put in while loop. And you can draw it here. And then what we're going to do is again go to the script drop and write down a simulate signal right here and put it inside the while loop. All right, when we see this pop up right here, change the amplitude to 10 and simulate acquisition timing. We're going to get it right, exactly right, like this. And then go to this output right here and we can create a graph indicator so we can see how the input turns out. And you've noticed on the front panel also we can see this graph right here. Okay, next what we're going to do is on the front panel, click again this quick drop right here and find and look for a vertical pointer slide like this. And then we can go to the properties and change the label into limit that we can change and also show digital display right here so we can see what are the limits that we are going to set. Notice on the block diagram we also have this function right here. And then next to the add the block diagram, again go to the quick drop and write down a comparison. So we're going to get a block like this. And then when we put it, we're going to get this pop up. Sorry. And then we're going to choose greater and change the comparison input into second signal input. And going to get it like that. And also on the front panel, we're going to need another one, which is brown LED. This will be our indicator. We can make it even bigger so it's easier to see. Going to its properties, we can change the label into alarm. Sorry, alarm right here. So this all the component that we're going to need. And next, what we're going to do is just make the wiring. So the first operand is going to the simulate signal block, and the others are going to the limits. And the result will go to alarm like that. And we also can do create a control to stop this simulation as soon as possible. And then what we're going to do is just start our simulation. And here's our how this system working. So basically, we can put the limits for the alarms going to turn on. So right here, our limits are 0. So if the sine wave are under 0, the alarm will turn off. And if it's above 0, the alarm will turn on. So we also can change the limit. Let's say I'm putting 5 into it. So the alarm will only turn on if the sine wave reaches above 5. For the real world example, for this system, it's actually very vast. If you use it for temperatures monitoring, if the temperatures reach a certain limit that we set, so the alarm will turn on. All right, guys. Now it's time for exercise number two, which is data acquisition in LabVIEW. The purpose of this exercise is to see how to collect data from a DAQ and store it and logging it. In this case, we are not using a hardware. We are just going to use um, this, which is Memax, to log as to act as a physical TAQ. So first, what we're going to do is just open this Max, and you're going to see an application right here. So first, just click on device and interface, right click it and create new. So you can see this pop-up coming out. Right click on the simulated in the AQ and click finish. We're just going to wait for a few seconds right here. And this pop-up will turn out. Uh, Click the plus buttons on the M series DAQ and look for the PCI 6221 and click OK. So we have our simulated device right here. If we have a physical device, a hardware, it will have a green icon, but in this case, we are going to use a simulated device. So the icon is yellow. Right click it and select test panel. Just wait for a few moments for it to come up. Okay, there it is. And here are our pop-up. So we just turn the mode to finite and let the rest be it. The date and the time samples and click start. And here are the waveform that we're going to get from the simulated DAQ device. Now we're going back to our lab view. First on the plot diagram, what we're going to do is again Control Tab and find while loop, create it right here as usual. And also we can create a control. So we have a stop button right here. And then what we're going to do is find the AQ assistance and put it inside the while loop. And again, wait for a few seconds for it to pop up. Click on data acquire signal, analog input, and next voltage. So we're going to have what this pop up to create where the device. We're going to choose AI0 and then finish. And this DAQ assistance will pop up. So it is very simple. What we're going to do is take the timing setting to continue samples and click OK. Just wait for it to build the IP. All right, there it is. And first, what we're going to do is create a graph indicator. So we have a graph right here on the front panel. And next, back to the block diagram, find time delay, put it right there, and set the time delay at 0.1. Next, we're going to find statistic. I'm sorry, this is the wrong one. Again, find statistic. Mhm. Right here. So when you put it on the while loop, you're going to get a pop-up right here. What we're going to do is choose what we want from the input so it can calculate it. In this case, we are going to choose mean, maximum, and minimum. So we have it right here. So take the signal take the signal and connect it to the DAQ assistance data. And on the output, we can create a numeric indicator. Sorry, the wrong one again. We can create a numeric indicator right here. We- I'm struggling right now. A numeric indicator, yeah, right there. For each of our output, mean, maximum, and also minimum. And we're going to have it in our front panel, so we can just make it look a little bit cleaner, like here. All right. Next, what we're going to do is going to block diagram again. We can find right measurement file. Okay, right there. Okay, here we can choose where our where to place our data. So I'm going to name it data right here. And next, tick on the save to series of files, and then only one headers, and also one column only here, and on the signal input, connect it to data DAQ, and there we got it. Our all the component that we're going to need is is ready, so we can run it. So this, as you can see on the front panel, are the data that we get from the AQ assistance are being displayed on the graph indicator, and it's already counting our mean, maximum, and minimum. If I stop the simulation and go to our data right here, we can open it with Excel, convert it, and just to make it look a little bit cleaner, to time, okay, right there. So as you can see, here are our data that we get from the AQ assistance, our voltage and the value. As you can see, it is very easy to log a data from the AQ into a Microsoft Excel. For a real-time usage for the system, we can use it on, for example, if we have QC or quality control, we can log the data from the sensors to count it means, maximum, and minimum. For exercise number 3, we are going to do math script. So the purpose of this exercise is to see how we can integrate a text-based coding into our LabVIEW. So first, we start as usual in the block diagram. We have to find while loop and draw it as usual. All right, right there, we're going to make it a little bit bigger than usual, and then find math script, math script notes, and also just a little bit right there. And then here is where our text-based code is going to go. So the code that we're going to use is right here. So we're going to paste it in the mass gray box right here, like that. And then with the system are already selected, we have to put the input, which is, as you can see here, we have few inputs. We right click on the border and add input right here. Add input number one, add input number two, and add input number three. We say this that the input will be flow, flow, F high, and also M. As you can see, the input are already in the code that we are going to calculate the input to get the output. So next, back to Control E to go to our front panel, Control Space to find what we're going to need, which is numeric control. We're going to need three of them, so you can just Control C, Control V, Control V. You have three of them right here. Going to arrange it so it looks a little bit nicer. Control E again to go to block diagram. Make it look a little bit nicer again. You can also rename it flow, have high, and finally M, and connect it into their designated input slots. For the outputs, we're going to have few outputs also, which is that the data that we calculated, which is input signal, S1, S2, and also output signal. So we just right click here, add output, and we can choose it from here so we don't have to type it again. So S1, add output, S2, add output, input signal, and add output, output signal. Then back to our front panel, Control Space, find waveform graph, put it right here. And we're going to need four of this because we have four outputs. So Control C, Control V, Control V, and Control V again. So Control E to go to our block diagram. As you can see, we have, wait, where is the another one? Okay. We have four waveform graph. Again, you just make it look a little bit nicer and rename them, which is S1, S2, input signal, output signal. And then again, just connect them to their designated places, like just like this. It's fairly easy. I think anyone can do it. Like that. And here we go. We are done. It's not that hard, right? So to run it, oh wait, I forget something. Control E again. We have to put a time delay. Control space, time delay. Put it right there. Change the time delay to 0.1. And also down here, don't forget to create a control. If not, you cannot run the simulation. Control E here, our stop button. Put it right here, like that. back to our block diagram, Control E. So we can run it back to our uh, front panel. As you can see, nothing is happening right now. But if we change our input right here, you can observe how the graph is changing based on our input. So if we put here 100, you can see this we put 0, this also we put 0. As you can see the output where the graph have changed, and if we change it to 10, you can see the graph also change. And if we put here, also the graph change again. The S1, S2 output and input signal. Back to our block diagram again. Here, I'm going to show how this could actually been executed. So right click and click probe. So you can see this pop up right here. This will be our indicator as what has actually happened in our code. And also right click here again, find probe. We can put it on the input signal and output signal. And notice we have this icon, which is start single stepping. This will execute our code one by one so we can see what actually happened. So if I click it once, you can see that first it goes time delay, which is 0.1 that we put earlier. And then it started to run our math script nodes and the code inside. What we're going to get first is actually our input that we have already put in, which is 10 for Fi, 100 for flow, and 10 for M. And then we click it again. It we going to the Fs. Oh, I forget to tell you that Fs is a sampling frequency. This is based on our system. So in this case, I'm going to just put it as 1000 and then run it again. It will read n, which is our simple sample index. And then if I run it again, it will calculate as 1, which is cost 2 times byte times flow, our input, and times n, which is our sample index. And we get the answer, but it will not show it yet. And then if we click it again, it will calculate S2, which is using F high. And then if we click it again, it will, as you can see here, where it is calculated the input signal. As you can see, we have calculated it here. Also, we can see the calculation, the result of calculation of S1 and S2 based on our input. We click it again, we get the number, and finally we get the output signal right here. So basically that is how our codes are running. So our real function, our real application for this are mainly on data analysis and so on. All right, guys, we have now comes to exercise number 4, which is report generation. The purpose of this report is actually to show how LabVIEW can generate reports such as measurement data and graph using this concept that I'm going to show you. First, what we're going to need is actually control space, signal, I'm sorry, simulate signal right here. And then we have to change a few things, which is right here. It's going to be a sine wave, going to add a little bit of noise, and then change the noise amplitude to 0.1 to make it look a little bit clearer. And then we're going to have a integer number of cycle, which is around 990. And that's all for simulate signal. And next, what we're going to need is spectrum measurement. Put it right there. Wait for the pop-ups right here. Few things that we're going to change is actually the selected measurement. We're going to select power spectrum, and the result will be linear. And then we can click OK. Put it down here, and just connect these two together, two and two. All right. Next, we're going to need a report plot. So this plot is actually going to do all the work to write ourselves a report. So in this report, we can have the title, which is in this case, I'm going to put it as data report, report, sorry. And after name, you can put your name, but in this case, I'm going to do Firdaus, a company, Unical, Unical MSI, like that. You can also uh, select what you want to put in the report, which is operator names, report print date, report print time, page number, and total pages. And the comment, you can put anything right here. Um, yeah, like that. And for the data input, you can see that we have few inputs right here. So the first one will be from the signal and the other one from the spectrum measurement. So what we're going to put is first one from waveform, and the x-axis we're going to label it as amplitude, like TUDE. And for the input two, we're going to put this as power spectrum. And the x-axis going to be labeled as also amplitude, like that. Then we can choose where to save our report. So click this and browse wherever you want. In this case, I'm going to be right here. Name it as whatever you want. I'm going to put data 2, and then you can click OK. Now we can go and connect this together, just like that. Make it look a little bit nicer. Change this to here. Now we are ready to run our program. Just a simple run like that. Okay, so you can see right here that it has been run. So we can see that our uh, file we have here that I have saved earlier, which is data2. So we can see the company, the title, the author, and the notes that we have put. You can also see the date right here, also with time. First, we have a waveform and also the data, the power spectrum. So this shows that LabVIEW can actually do automatically report data as it's one of its functions. So in the real world example or real world application, we can use it to automatically report and experiments results or print our result as we want it, just automatically, so we don't have to do it manually. Now we move on to exercise number 5, which is a remote panels. The purpose of this exercise is to show that LabVIEW can show data to a web page remotely or automatically, so have our we can see our data from web page. So let us do our exercise first. Go to tools and then find a web page publishing tools and then select what we're going to do, which is in this example exercise 2. Yes, and I forgot to mention that we're going to continue our task number 5 with task exercise number 2 that we have did earlier. And then we have viewing mode, which we're going to select monitor, and then we can change how many updates per second. I mean seconds between the updates. In this case, I'm just going to put one, which is the word limit. And then we have to press start web server, but I already done it before, so you just have to click it right here and then go next. Here we can put anything as the document title. In this example, I'm going just to put in data monitoring. You can see the preview right here as the header, and also we can change the header to, let's say, LabVIEW monitoring, and also the footer right here. Change it to whatever you like. In this case, PN, and then just click next. Here you can change the profile name. I'm going to change to file and then save to this, which is the directory right here. And then you can just hit connect and it will bring you to uh, the the page. So as you can see here, before I run it, it don't move. But when I run our program, you see the data is changing right here. And if we go to our browser, you can see the monitoring. But after 2016, before 2016, we can control the LabVIEW from our browser, but after 2026, the features has been discontinued. So we only can monitor the progress or the process of LabVIEW. As the real world application for this particular function is for data monitoring. If we have a hazardous places, let's say a contaminated power plant, we can use this system to see the data on that particular place. That is one of its real world applications. We have come to the end of our exercise. I hope you guys learn a little thing or two about LabVIEW and its purposes and functions. Until next time, thank you.